In 4.6, we're still talking about triangles, okay? This whole chapter is about triangles. In fact, let's see. This could possibly be our last section. There's two more sections in here, but I know I'm not going to do 4.7. I'll have to think if I'm going to do 4.8 or not. So this possibly could be our last. So there's a chance we will have a test on this before the midterms, okay? I'll have to think about it tonight. I'll let you know tomorrow, okay? So anyway, 4.6. Still talking about triangles, and we're going to talk about triangles that we have discussed before. For instance, let me spread this out a little bit. Make it a little bit bigger so we can see it. Look at this triangle right here. Now, if I mark this triangle with some tick marks, let's call it ABC so we can refer to the sides and the angles. And if I put a tick mark here and a tick mark right there, what is the name of this type of triangle if I put two marks right here? It's isosceles, right? Because isosceles triangles, at least two of the sides are equal. And let's please try to spell it correctly. All right, I don't mark off for spelling, but it's just nice to be able to spell stuff correctly, okay? So we're on the same page on this. Isos, I-S-O-S, and then celes, C-E-L-E-S. Still get some of you guys just butchering the spelling of this, all right? So just please try to spell it correctly. It's nice if you spell things the right way. So it's isosceles triangle. Here's what we know a few things about this isosceles triangle, and I don't know if we talked about these words when we first talked about an isosceles triangle, but we're going to now. We're going to learn just a little bit of vocab, all right, on this. Joe, you can put that away. You don't need that now. So these two sides that are equal to each other, we call these the legs of the isosceles triangle. So if I talk about the leg of the isosceles triangle, it's talking about one of those two equal sides. Everybody see that? So the two sides that are equal are called the legs. This side right here is the unequal side. It's the one that's not equal. We call this the base of the isosceles triangle. Okay? I've got legs and I got bases. Everybody with me on that? All right, pretty easy. Now we also have some angles. Look at this angle right here. I'll just point to it. This angle B right here, look what it does. It's an angle that's formed with the base. Do you see that? If I put a little arc right there, that arc will touch the base. So I call that a base angle. And this is also a base angle. All right. Now this angle up here that doesn't attach to the base, right? It doesn't come in contact with the base of it. We call this the vertex angle. This is just vocabulary, all right, just so that you know, if I refer to the legs of an isosceles triangle, you know what I'm talking about. If I talk about the base of an isosceles triangle, you know which side I'm talking about. All right, that's why we learn vocabulary. So when we say words, everybody knows what we're talking about. All right, so that's what we have right here. Pretty simple stuff, okay? That's just vocab stuff. What we're going to do now is we're going to talk about a theorem, actually two theorems for this. And let's mark, it's still isosceles, still the same exact triangle, just copied and pasted it. So this side and this side are still equal to each other. And let's just call this DEF this time, just to make it different. Now here's what the theorem says. Now this is an isosceles triangle, so it's kind of nice of them to call this the Isosceles Triangle Theorem. This is what the Isosceles Triangle Theorem says. It's not very difficult, but it's very important. You're going to use this quite a bit. So if you have, the Isosceles Triangle Theorem says, if I have two sides that are equal to each other, an isosceles triangle, it says that the angles opposite those equal sides are also equal to each other as well. All right, that means that this angle E is equal to this angle F. So what did they tell us to begin with? They didn't first tell us that the angles were equal. They said what? If the two sides were equal, right? So let's write it down. It's kind of like a little shortcut way of writing it. If two sides of a triangle are equal, then the two, we'll call it opposite angles, would be equal to each other as well. Everybody see that? Well, opposite the two sides. See how this angle is opposite this equal side, and this angle is opposite this equal side. Or you could say the base angles, couldn't you? All right? You could say the base angles would be equal to each other. So on an isosceles triangle, the base angles are equal to each other. They would be the angles that are opposite the two equal sides. Does that make sense? That's very important. It might not be that big of a deal to you, but we're going to use that a lot, and it's really going to come in handy finding missing angles and solving for x and all the stuff that we've been doing all year long. Right? Everybody got that? Now, I'll tell you what, I'll do this in another color. Well, now let's just draw the whole thing over again. Copy this. Put it right here again. And let's mark it in a different... sorry. I'm going to keep that white. I'm going to make my next one red. Okay. Here's what the next thing says. What did we say before? We said if the two sides are equal, right? So it was given that the two sides were equal. If the two sides are equal, what can we say about the other two angles? They got to be equal, okay? But we were given. What was our given? That the two sides were equal. We're going to do a thing called the converse. The converse is you switch the if and the then statements. So this is the converse of the Isosceles Triangle theorem. I'll just shorthand that. Okay? Here's the converse. The converse says this. If the two angles are given equal to each other, so they tell us that the two angles are equal. If that's all, they stuck a triangle here and they said this angle and this angle are equal to each other, what do you think you could say? Then the two sides are equal. Exactly right. So it's just kind of like the opposite, isn't it? All right. Instead of saying if the sides are equal, then the angles are equal, it says what? If the angles are equal, then the sides are equal. So look, if these two angles are equal to each other, that means that this side is going to equal this side. You look at it and you're probably thinking, it's the same exact thing. But it's really not, is it? The first one said, if the sides were equal, then the angles are equal. What does this say? If the two angles are equal, then the two opposite, that's supposed to be opposite, sides are going to be equal. Do you see the difference? All right, the if and the then switched places, didn't it? All right, so that's the converse. When we talk about a converse, that's what we do with a converse. All right, so for instance, I'll tell you what, let's do this instead. Let's get rid of this and get rid of this. And let's say that was 30, and let's say that was 30. And I don't know, we'll just make it super easy. What if we said that's 5 and we don't know what that is? All right. So it's pretty simple. These two angles are equal to each other, right? If I know this side is 5, tell me what this side's going to be. It's going to be 5 as well. Everybody see that? Because if the two angles are equal, right here, if the two angles are equal, then the opposite sides have to be equal. So if this is 5, that has to be 5 as well. All right. Now, it's not going to be that easy. They're going to give you stuff like this. I'm just making this up. So they're going to say, like, this side would be x plus 1, and this side might be like 3x minus 2 or something like that. All right. So if I asked you to solve for x or actually find the lengths of this side, you should be able to do that, shouldn't you? I don't know if this comes out even or not, but let's just give it a shot. Maybe if I did, let's see, maybe if I did this, it might work. Let's try that. I just did those numbers off the top of my head. So what would you do to those two? You'd set them equal, wouldn't you? X plus 1. So we subtract an x from both sides, that's a 2x. We add a 3 to both sides, and that's a 4. Divide by 2, x is what? 2. So x is 2. What would the length of this side be right here? 2 plus 1 is what? 3. So that side is 3. What should this side right here be? It should be 3 as well. Does it work with the numbers? Yeah, 3 times 2 is 6, minus 3 is 3. So that side would also be 3. We've been doing that all year, haven't we? All right, you look to see what stuff's equal to each other and you make them equal to each other. Is it really any different than stuff we've done before? Not really. It's just a matter of understanding if these two angles are equal, then these two sides have to be equal. And you just set them equal to each other. Make sense? Okay. Let's do another one. We'll use the same triangle. Actually, let's not use the same triangle. Let me go back up here and I want to find this triangle. Now we'll go back to here. There we go. I want this triangle right here. It's a little different. This is actually an equilateral triangle. What does it mean to be equilateral? All the sides are equal, so let's mark it. So this side, let's make this a little thicker. This side is equal to this side, which is equal to this side. Now, I want you to see how the theorems that we just talked about really come into play here. This is actually kind of interesting to see how this works. Now, look at this. We know that this side right here, let's just call it PQR. So we know that PQ is equal to PR, don't we? So with that said, what do you think I can say about the angles here? Which angles? Actually, all of them will be eventually, but let's say because of this side equals this side, then what? Then angle Q is equal to angle R, isn't it? Okay. But watch this. But this side right here is equal to this side right here. So the angles opposite those two sides must be equal as well. So this angle must equal this angle right here. So if this has one arc to it, how many arcs should this have? No, just one. If it had two, that means that this angle would be different than this. But what did we just say? We said that these two angles are equal, right? Because they're opposite equal sides. You get it? So I've got equal sides. These would be equal angles. Now look at that. What can I say about all three of these angles? They have to all equal, right? Okay, so all three of these angles are equal. So we called that triangle, to begin with, we called it equilateral, didn't we? Okay, so an equilateral triangle must also be, what do you think? Equiangular. I think we might have mentioned that before, but we didn't really show why. Now we're showing why. Okay, so if you start off with an equilateral triangle, all three sides are equal, that automatically means that all three angles are going to be equal. That's going to happen every single time. It'll always, always be true. It doesn't matter how big or small your triangle is. Okay, I could have a little triangle like this. Okay, if all three sides are equal to each other, that means all three angles are equal to each other. It doesn't matter how big. As long as it's equilateral, okay, as long as it's equilateral, it means it's also going to be equiangular. But what about the other way? What if I didn't know that these three sides were equal? What if I just knew that these three angles are equal? What do you think you might be able to say? The side's going to be equal too because of the converse. Remember that? The converse of the isosceles triangle theorem. So look, if these two angles are equal, what does that mean? It means the two opposite sides are equal. Let's do this one. This angle and this angle are equal to each other, so the sides opposite those angles have to be equal to each other as well. So look, this side has to equal this side. If that has one tick mark, that has one tick mark. Everybody see that? So it works both ways. If the three sides are equal, the three angles are equal. If I tell you the three angles are equal, that also tells you what? The three sides are equal. Okay, so watch what I could do with this. I could put, they do this sometimes. They'll put an arrow this way and an arrow this way because it means it goes both ways. If it's equilateral, it's also equiangular. If it's equiangular, it means it's also equilateral. All right? I think that's kind of interesting. Here's something I think is even a little bit better than that. I didn't tell you any of these angles, did I? I didn't tell you any of the values of these angles. But you can figure out what all three of these angles are actually equal to. It's really not that difficult. What do we know about the angles inside of a triangle? What do they add up to be? They add up to be 180, don't they? Now look at all three of these angles. All three of these angles are exactly the same. I told my last class this. If I had $180 and I picked three of you and I was going to distribute the $180 evenly, I was going to give all three people the same amount of money, okay? How much money would I give all three of those people if I had $180? $60 a piece. How did I get the 60? I took 180 and did what? Divided it by 3, right? It's the same thing here. These three angles add up to 180 degrees. These three angles right here add up to 180 degrees. And if I wanted to distribute them evenly, right, all three of those angles are equal, then I just divide it by 3, and that's 60 degrees. So that means this is 60 degrees, so is this, and so is this. All right, without telling you any of the angles, you could have figured out that each one of those was 60 degrees. Does that change if my triangle was a smaller equilateral triangle? What if it was a real tiny one? Does that mean it's smaller than 60 degrees? No, because even if it's a small triangle, the angles are still the same. The cool thing about this program is this. I couldn't do this on the whiteboard, but watch. I could take this one, put it up top, and look, that angle's exactly the same, isn't it? You see it? All right, and I can take it. If you don't believe me on the other three, see, that bottom left one's the same, and over here that bottom right one is the same. Now the size of the triangle is different, but the angles are the same. I've had people in the past say, well, the triangle's smaller, then the angles have to be smaller. It's not true at all. Okay? The sides are smaller, absolutely, but the angles are still exactly the same. All right? Like if this side was 10, this side's probably more like 2 or something like that. Okay? But the angles are still exactly the same. And a lot of people get confused on that. But the angles are all 60 here. They're all 60 right here. Does that make sense? Let's do a quick example. We got a couple minutes left. Let's do this one right here. This is not equilateral, it's isosceles, so we'll make it look something like this. This is the kind of stuff that you're going to be doing. I'm going to give you a worksheet on this, and this is the kind of stuff that it's going to look like. They say this is 80 degrees up here. They say that these two sides are equal to each other. They said this angle down here is 6x plus 8 degrees. And this side is 2y plus 2. And this side is 4y minus 2. Alright, here's the information they give you. And guess what they ask you to solve for? They ask you to solve for what? For x and y. Alright, so let's take a look. Is it easy? I hope it is. Let's take a look. First of all, these two sides are equal to each other. Oops. I did this. Ooh, I messed up in the other class. I made this an x instead of a y. Oh well. That's okay. What are we going to do? These two sides are equal to each other. This has a y in it. This has a y in it. So what can I do? I can set them equal to each other, okay? We don't have enough time to go through all the math, but you could do that on your own. All right? You do all the work, right? And then you get y equals whatever. All right? Look at this thing right here. Freddie. Don't. Yes. What do you think? How about both then? Look at this right here. Let's solve for x. Do I just set these two angles equal to each other? No, because this angle right here is equal to this angle here. So this is also what? 6x plus 8. Now, what do am I done? What do? I add them all up and set them equal to what? 180. So I got 6x plus x is one angle, and then I got 6x plus, 8, not x. 6x plus 8 is another angle, plus what else? 80, right? And that equals 180. I'll let you do the work, and you get x equals whatever. All right? And that's how you do it. Make sense? It's not going to be all exactly like this, but that's the idea. That's the idea what you're trying to do. Equals 50? Don't think so. Where'd you get 50 from? Oh, I see what you're saying. Yeah, you could do that. Yeah, I didn't even think of that. That's a good idea. Did you hear what he said? Look, the whole thing's 180. If I take 80 away from 180, that's 100, right? So that means these two add up to 100. If they're both exactly the same, they have to both equal 50. Yeah. All right, let me give you a worksheet before you go.